The definition of the inverse of a function, and then I'm going to read this and then I'm going to put it in my own language, okay? It says, let f and g be two functions such that f of g of x is equal to x, meaning for every x in the domain, for every x in the domain of g, and then g of f of x is equal to x, for every x in the domain of f. Now, basically what it's saying here, we can find a, there are some equations where you could, you have a function, and then when you use the composite function method, and take its inverse, we'll talk about the inverse, it's going to equal to x. That's what this is saying, okay? So the function g is the inverse of the function f, and is denoted by. Now, when we talk about inverse function, you have f to the negative 1, but it's not f to the negative 1 where you're talking about the exponents. Okay, there was a notion in your textbook that I was looking over, but you read this as f inverse. Okay, f to the negative 1 power, it means f inverse. Okay, thus f inverse of x is equal to x, and then f inverse of f of x is equal to x. Okay, so we're going to do some of those. It says the domain of f is equal to the range of f inverse and vice versa. So, when I think of inverse, the best way I can say this where you will understand, let's say that you are tying your shoes. Well, that would be something real simple. You're tying your shoes. That would be your function. Okay, that will be our function, our f of x. Our inverse of that would be untying them. So inverse means we're going to undo. Okay, so I'm going to write this up here just as a refresher. An inverse function is a function that will undo anything that the original function does. Okay, here again, an inverse function is a function that will undo anything that the original function does. Okay. All right, so we have an example. It says find fg of x and gf of x to determine whether each pair of functions f and g are inverses of each other. And you would know that because when we find f of g of x and gf of x, it's going to equal to x. Okay? So, here we go. Example A. We have here f of x is equal to 3x plus 2. And we have g of x that is equal to x minus 3. Okay, so first we're going to show that we want to find f of g of x. So what this means is that we're going to take our function g, which is x minus 3, x minus 2 over 3, and we're going to substitute it into the equation for f of x, for the variable x. So we're saying here, 3 times, okay, what are we going to put here for x? Help me out here.
X minus 2 over 3.
X minus 2 over 3 plus 2. Now, that 3 times x minus 2 over 3, what's going to happen to the 3's here? It cancels out. And we have x minus 2 plus 2, and x minus 2 plus 2 gives us x. Okay, so determine whether each pair of functions f and g are inverses of each other. Well, the first one, yes, because we get x. G of f of x. Okay, so where we see taking our g of x equation, x minus 2 over 3, where we see x, we're going to plug in that function, the expression for f of x, 3x plus 2. So here you go, 3x plus 2 minus 2 all over 3. What happens to the 2's here? Yeah, then you have 3x over 3, and that gives us x. So, are they inverses of each other? We can just say yes, they are. Okay? Okay. We have here f of x is equal to 5x minus 9, and we have g of x that is equal to x plus 5 over 9. Now just look at it compared to the other ones, to the first example. Now I already told you that this one is not going to be, we would say no, that these are not inverses of one another. Because think about it, we're looking for the inverse of minus 9, which will be plus 9, and we're looking for the inverse of times, which would be divide by 5. Look at what we have. Yeah. So we can tell that they're not going to work out. So let's look at it. Let's just verify it. Verify why is no. So we're looking for f of g of x. So we're going to take the expression of g of x, which is x plus 5 over 9, and substitute into the equation for f of x, for the variable x. So you're saying 5 times, what are we putting for x? X plus 5 over 9 minus 9. So you say, okay, Miss Lewis, what are we doing here? Okay? All right. Well, we can make this 5 into a fraction by placing a 1 under it. Okay? And you know how to multiply fractions, numerator to numerator, denominator to denominator. So we take this 5 and distribute to the numerator. So you're saying here 5x plus 25 all over 9 minus 9. And we can leave it as this because no matter what, no matter how we try to simplify this, it's not going to simplify to x. That's how we would know if two functions are inverses of one another. They're going to simplify to x. Okay? So we're going to stop here. I mean, we can take it further, but there's no need to because we know it's not going to happen. Now, the g of f of x, okay, so we're using the, we're going to substitute the expression 5x minus 9 into the equation for g of x. So you're saying here 5x minus 9 plus 5 over 9, adding negative 9 and 5, we have what, 5x minus 4? And we can stop there because it's not going to simplify to x. So we would say no, they are not inverses of each other.